So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 149, and in this video we continue of course with our repetition of keywords, and not only a repetition, of course we extend our knowledge as well. And like all time, I will read here the question. You should pause the video and try it before I explain it, and then after you tried it you can start the video again and see what I'm talking. And my answers are not perfect, but don't worry, I will refer anyway to the web page here on the official documentation of CPP reference.com. And the reason for that is, of course, we won't try to understand this documentation. Our goal as a starter is to understand later the official C++ documentation, so we can watch all keywords on our own, understand how to use them, when to use them, and why to use them. And for this purpose, we are doing this repetition and including now a little bit this page with CPP reference.com. And let's get started, I would say. Here, let's read the first question. It says, what is keyword static? Why we need it? And make an example. All right, so what is keyword static? Static is actually a storage that's true. It's a storage specifier, but the name storage specifier, it's a little bit misleading because it's not only for storage, it's also for linkage. So let's write here specifier for storage and linkage. For storage and linkage. Yes. And scope is also a little bit important, but let's say this one. We will see this later a little bit more specific. And yeah, but the interesting is here I wrote here storage and linkage, but what means storage and linkage? And what this mean, we will write this later, because here I ask this separately, because it's very important to watch this separately. But here, why we need it? The static keyword, why we need it? Yes, to use it. No, that was not the right answer. Of course to use it, but why we need static? And I can answer this question here only when I compare it to other things and say why we need it and why we need not the other things or something like that. So let's skip this answer here, because that will be later a little bit more clear when we talked about storage and linkage. And then this question is absolutely clear why we need it, because this will distinguish the storage and linkage from other use cases. And then no problem, then we know it, why we need it. And make an example. Yes, try this one here. This one we can make an example, which means if you know already static keyword, you should be able to do an example. And I did already an example here, so that I don't waste too much time writing it. And I jump here down, and what you can see here is this one here. Here I created a function, a void function, which means no return type. Name, I just called it test static variables, and no parameter. And we have here the scope, which is my curly braces here indicating the scope starts here. We see this white line down here. And what we see also here is we have here a variable declaration. What declaration is this again? A copy declaration with an assignment. We can see it here. And I assign it here the value 0. And it is a static int variable. I called it my incremented number because I want increment it. And here the second line, I just used the long way to increment it instead of plus the short way. You know what I mean? You could increment this one with this shortcut, my incremented number plus would work also, but It can irritate here for this demonstration purposes. That's why I use this way, so you can see what will happen in a moment when I started, later when I explain the storage and linkage. That's why I made it here, in this case, the long way. And here I just put it out this variable name. And here you see again a variable, but this variable is not a static variable, a non-static variable. It's that what we all time used, and I called this my increment number 2, but this time just a normal int, and you can see that's incrementing here 2, and then I print it out. And here on in main I'm just calling it one time, and when I calling it here one time, this function here on top, what happens is it prints just out what I defined here, and you can see this one and this one is expected. But what happens if I call it a second time? What you expect is, so when I start it, then you see there is something different here. The first time was this one here where it says 1 1, but I called it here the second time, and you can see now it says 2 1. The first 2 here is my static variable. The 1 here is my normal variable, and my normal variable is again 1. And why this so is, and so on, I will explain it with the other questions, because I split this a little bit. So first of all, before I explain anything, let's go to the side and read what a static really is, because this one is not absolute correct. Let's see what correct is. So it says here, not in fundamental types, in I think we will jump there. Here we go to static. When we have it here, we have it. And before we go in static, we see that static has has different meanings in different places. We have not talked about this one here, which means a class member. This kind of static we don't know. We will talk later when we learn class, structs, and this kind of stuff. But right now we know this one here, namespace manager with static. I think we talked about this one here, and the other one is on the same page here. That's why we will use this page here, and this page says storage class specifier, and my was specifier for storage and linkage, and here is the real answer. Okay, it's a storage class specifier, and I wrote not this here down. The reason for this one is a little bit confusing. It's not wrong, it's confusing, because when you read now this one here, which is the real answer, then you will see why. It says here the storage class specifier are a part of the declaration specifier sequence. We know now what this one is, right? We have discussed this. This is just the sequence which becomes in front of the declarator, or what is called the identifier. Here in my example, what is the declarator specifier sequence here? Can you know this? I hope you know it. It is just int in this case, and this one is my declarator. We have trained this, I think, a little bit. If you don't know it, no worry. We learn it step by step, but this kind of words comes all over the place again and again. So we will repeat this many times, and later you are very familiar with these words better than me, so don't worry about that. But the important part is here the second sentence actually. When you read now this one here, it says together with the scope. Okay, I should write here in my answer scope as well. Together with scope, I forgot something. Specifier of storage and linkage. Together and scope. Let's write here and scope. Specifier of storage and linkage with scope, not end scope, with scope, huh? That's more correct. All right, so we get this one here, and read this one again. Together with the scope of the name, yes, with the scope of the name, they control two independent properties: the name of the name, and it is storage duration and its linkage. And that's why I said this one can a little bit irritate it, because when you read here just storage class specifier, you think only about storage, and we will talk about the storage here a little bit. It is this storage here, but more in detail, it's the storage duration. And we have to think about this kind of stuff also with linkage, because that's very important as well. And yes, with the scope in scope means here where this variable name is defined, in which scope, and it depends on this, and this can change. All right, we will talk about this in a moment a little bit more in detail. And when we scroll here down, of course you can here read, but here skip all these other things which we have not talked. For example, this one, this one, this one, this one. We have not talked about all this kinds. The only thing which is interesting is perhaps this one. Our internal linkage here. This one is very important. The static keyword. If you use the storage specifier, let's make an example in mind. Let me say this. For example, I use this variable with the keyword static. This variable here has now internal linkage. That's very important. When I compare it with this other one here, which we all time used, this one has, in this case, that's very important, in this case, no linkage. And the reason for that is, careful, we have to consider all time the scope. It says with scope. We have to check in which scope it is here. I have a function, and the function scope starts here, ends here. So we have to check where we are. So in this scope, and in this scope, this variable here, what we all time use, has no linkage. What no linkage means, we will see in a moment. And my static variable here has internal linkage. These are words which we don't know. Don't worry about this. It will be described in a moment, and I will start this program again and explain this, why we have this output there and there. So let's continue what is important to know with our question. Let's go back there for a moment. And it says here, okay, this one we have defined a little bit. Important is, okay, why we need it. Later when I define what storage duration is and linkages, then we will know why we need it, because we need first to understand what this means, this storage duration and linkage with the scope. Then we can answer this question here. So we skip this and answer it later. Make an example. Yes, I made there an example, but I have not fully explained this example, and we will make this also later after I explained these two things. And this two, storage duration and linkage, when you scroll down here, we have here an explanation. First of all, we need to know that static has internal linkage. We start here. Then we have here a little bit more explanation. You can read this one a little bit through. And then here the two very important things are defined here. Storage duration. What we need is the static, this automatic. So we need to read this two here, define this one, because we will use this. This thread you can skip, and dynamic you can skip now too. And then what do we need next is this linkage. And here what we need is internal linkage, because we just read that static is internal linkage. So we have to understand what this means a little bit. And no linkage is also very important. Normally this one is also important, external linkage, but you can, yes, skip this one for now. And we will anyway not go too deep into linkage. The reason for that is we have not learned how to deal with different files. So we will make this linkage very, very, very short, and perhaps you don't understand it in this example, not really. And the reason for that is we need to handle different files. And what I mean with different files, by the way, different files is, you see we have here on top, it says first project CPP. This is one file, but soon we will learn how to have different kind of files. And when we have different kind of files, this linkage becomes very, very, very important, because the compiler says then, can I read, for example, a variable in this other file, which is here defined, and so on. And that's why probably we will go only short about this one, but still you should read a little bit about linkage, and all what I can't define like all time, read in official books, papers, and online documentations where it is much better explained and so on. But let's go back to our question, which says, what is keyword static? Make an example. Okay, this example we made, we will explain this example in a moment more, and let's go to the next question here. So we will come back here in a moment after we define this other questions, because they are exactly asking for that. Here, 60, it says, what is static storage duration? And why we need to know about it. So it is this time exactly asking about what is the static storage duration. And I said just concentrate first of all here in these two ones, because we will need and discuss now. And you can, perhaps you know it, perhaps not. I think we talked about them very shortly, not very long in this tutorial, because I said this is again so a theoretical part which you should read on online documentation. It's hard to explain in a practical way, but yeah, let's try it. So what is static storage duration? We can say static storage duration. Yeah, well, now we have to describe the storage duration. So the lifetime of a variable, for example. And if you read static, then it means the lifetime, let's write here something randomly, the lifetime of a variable will be kept till the program is closed. And perhaps you don't understand this one now, but I will demonstrate this one in our example in a moment. But before I go there, yes, we can go there and I demonstrate it. And let's see why we need to know about it. Yes, with the demonstration, I will show you this question as well. And let's dive into the demonstration. So we are interested now in storage duration, so not in linkage. And yeah, like my example from before, I have here my static variable. And what I said is this is in the scope of this function. That's very important. And it has a internal linkage, which is right now not so important because we are concentrating now on the storage duration. And when I start this program, I started it before and it looked a little bit strange that I have here 1, 1 and 1, 2. And the strange thing about this one was why the second one, which is a normal variable, which we declared so far without static, is 1. And this one is 2. So the irritating thing is not this one here. This one was expected, but this one was not really expected, because let's watch it again. What happens is I call here the function. It jumps on the top, and on the top it says, okay, I jump here, then I jump to the scope, then I jump the first declaration. I initialize this variable name with 0, then I increment this variable here by 1 and assign it to this variable, and I put it out. This one is exactly the first one here, right? That was my first call. And of course it do the same thing with our normal variable without static, which means I go in here the first time I declare to 0, I increment this by 1 and I put it out here. So this is this one here. So both are absolutely clear for us, right? Okay, let's go to the next round. The next round, I call the function here again. Exactly what happens is it jumps again here, but now something different happens with static. And what happens here now is, because static has a yes, static duration. Let's see what it says here. What was it? It says a static storage duration. So this one has a static storage duration, means, like I said, if you declare this variable one time, it will save behind the scene in this file here where you have declared it, and it is not destroyed after the declaration of the first time till you close this window program, which means, because, oops, not this one, this one. So that means because I run this one first time and I go now here to the call it second time, and this variable was not destroyed after the first time, this one existed behind the scene, and this declaration here is skipped because it saved this behind the scene. We don't know it. The static made this one. It saved this declaration behind the scene, and it saved not only the declaration here, it saved also the value and the new assigned value. So this is behind the scene one, which means when it will not go in this line, it will skip more or less this line. It will jump to this line, and it will just use the save variable behind the scene, which means I increment 1 by 1. So my output is 2, and that's my 2 here. So static storage duration means it was not destroyed. But when we watch now the other variable, which we normally use, this is the variable till we used most time in our declarations. And here is it not. Why we have here a 1? And the thing is, in my second call here, it jumps here, it finished this one. Here we have 2, okay. But here it jumps to this line and says, oh, you are not static, which means I have not saved you behind the scene. You was destroyed after this scope here, so it declares this variable again from new. You get 0, it assigns 0 to this variable, and then it increments this 1 by 1, and then it puts out. So with other words, I get 1 again. So, and that's why it's very important to consider the scope here. The scope here says for normal variables, which we used, this one here, it says here, they have no static storage duration. They have actually, what they have is this one here. It's called this automatic storage duration. And when you read this one, what automatic storage duration means, it means here just, it will be, it lives only as long as the code block anything. You can read this one here. I show you what it means here in our code. It means just this one is declared here. It is assigned here. It is printed out here. But end of the scope, this variable is also destroyed here. Which means if you call this function again, this one needs to be called again, created again. So it will jump here again on the second call here. Because on the first call here, at the end of the scope, it was destroyed. In the second call here of the function, it goes here and creates its new. And this static here, it's not creating new. That's the different. And that's means static storage duration means it is safe behind the scene in this file here. Very important is also that you know it is only in this file here, the CPP. If we would have more files, it would not count for other, only for this one here. So I hope this one is a little bit clear. If not, no worry. Step by step, we learn it. And read, of course, the online documentation. And of course, if I call it here, let's make this one as well. Here again, what will happen now? Because this one was stored, it will now even go to 3, and this one will still stay by 1. That is my expectation, at least what I expect. And nothing happens because this program makes sometimes this strange thing. But the output is expected. First, 1, 1. Second, 1, 2. This is incrementing. And my third, it's now by 1, 3. Expected, right? Because what was it? This is saved behind the scene and is reused. And in this call, for example, this line is again skipped because they know I know you. It says I know you, so I declare you not again. I just use this line here. I increment it, and that's why we have here a 3. All right, I hope that was a little bit long, but I had to explain this long because the linkage I will explain very short because it's, let's say it's too complicated right now to explain it online with the linkage here. Let's go here and say 60. What is the static storage duration and why we need to know about this? Because let's write the second one now here. Why we need to know it, so we know which values will be stored or destroyed in scope. And that's why the scope is also very important here, by the way. All time think about the scope, because here also automated, here read this one as well, automated storage duration. We have a scope here in this case, but careful, we have there another thing soon too. If this one is, for example, in global space, later we will talk about this one, then this one change a little bit here. But if you understand, this one here is good. So let's go to the next one. I think that's okay for this one. And here 61, it says why is static link what is static linkage and why we need to know about it. And I said I will not talk about linkage too much in this video, because the problem is with linkage is to explain it very nice so that you can follow it, I need here another file, and then I could show you exactly what linkage is. That's why I will show you what linkage you should read. At least you should know static. Here it says here on top, static has internal linkage, but the problem with linkage is you should not confuse with linkage with access. Internal linkage, when we read here this one here, the first line at least, it says here the name can be referred to from all scopes in the current translation unit. The translation unit is in my case this one CPP file. If I would have here more CPP files, that would be another translation unit. So, and the problem is, like I said, I need here other files to show you this exactly. But here another thing which is very important, and don't get confused if you read this in other online documentations and good books, and so that you don't confuse referred from all scopes, that you think you can access it. Many get confused with access and referred. This referred here means the compiler, not that you can access it, the compiler. They are talking more about the compiler here. And yeah, that's I think what I have to show you when we talk about this one. But here, let's see, the no linkage is also very interesting. The name can be referred to only from the scope it is in. Yes, yeah, let's skip this one here. And because I said I will need to talk a little bit more about compiler access, and here there's different files, but of course read this one again in theory, in good explanation books. At least read this one here, this internal linkage a little bit, but will be hard to grasp a little bit, because you need to understand these different file systems, what it means, and they will explain it with this one. but you can read it a little bit, and no linkage and external linkage if you want to. It takes too much time. This is almost, yeah, that will take much time just to explain this one. That's why I skipped this, but you should read this a little bit so you get, let's say, some ideas. But if you don't understand it, no worry, no worry. Important is that you understand something like a simple example like this, something like that you should understand, and why this number is growing here and this one number is not growing here after I called it 3 times. This kind of stuff you should understand. The linkage later. Let's skip this. So let's go to our things and let's say what is static linkage and why we need to know about it. Let's say static linkage, yes. What is static linkage? Let's get, there is no static linkage. It means more like static linkage. No, it is called static has, let's write here just so static has internal linkage and is important for the linker in clamor. Let's write a compiler. Yeah, not for us. So, but we will make there other things, right? So, and yeah, let's go here to the next question. And it says here 30, what is the difference about global variable and static variable? Yes, that has again a thing to do with linkage. That I want to skip a little bit, but let's see. But important here is I can show you in this example, like I said, you should at least understand this example here. When here, this normal variable here, what I declared, it is different when I declare this one in global space. I don't know what this one is. Let me comment this one and cut this out for a moment so it's not irritating too much. So, yeah, back. So, when I have this variable here, it is different when I have this one here. Why is this different? First of all, this one is local, right? This is in the scope of this function here. But when I have this variable, let's copy this one here and make here another one. Here on top, this has now, this is in, let's make it free, and this one is now global space, a global variable. Let's write here global variable. And let's say this one as well. Let's copy this one here because we are comparing now this two at least. And make here number 3 too. So here the question was, what was the question here? Question was now, what is the difference about global variable and static variable? Exactly that what I showed there, right? So what is here the difference? Here we have shown what the difference is. Here in this case, it is storage. Yes, it has the static storage duration, which means it is safe behind the scene, which means this variable gets not destroyed. But here the global variable actually get not destroyed too, right? When we show this one here, because I can use this here anywhere in this program, and this one here goes not destroyed as well, at least not as long it is here. So what is here the difference? In this case, it's a little bit harder to say what the difference is. That's why we need now again talking about linkage, and it says here this static int variable has internal linkage, which means in short you can, the compiler, let's say the linker, sees it only in this file, whereas this one here has external linkage, which means if we have here more files, then this one can create name conflicts because the compiler can see it in other files. I know this is, again, I talk about linkage. We have no clue what this really is, as long as I have not made here an example. And that's why I skipped this. I skipped this question as well. I don't know why I have these questions here if I can't use them. That's strange. Why I have, perhaps I thought you should still watch this a little bit, because this kind of stuff here is important to know. Yeah, a little bit. It's more talk about linker actually, not more about static. It goes a little bit out of scope, I think, because I wanted only specify here the static keyword and not all this kind of linking things. But okay, let's skip this as well. Let's say here, what is the difference about global variables and static variables? Let's say global normal variables. Global variables which are non-static have external linkage by default, and static variables variables have internal linkage by default. All right. So let's write this one, and yeah, you have to read this a little bit more. Like I said, this whole question with linkage we should skip here, but read this one. It's very important later. If you don't read it, if you don't understand it, no worry. Understand, like I said, if you understand this little program here, this example what I made, and why it happens, goes up when it is destroyed, and why, yes, all this question what I mentioned before, if you understand this and can use that, that's good. Let's start. I mean, yeah, starters, at least we know this one and we can use it, and yeah, and let's go on. Let's see what we have. I hope we have no linkage questions here again, because we will skip them. So here, verse 64, it says here, for what we need a switch statement. Okay, thanks God, it's not a linkage statement. Okay, for what we need a switch statement. Explain the examples on the page. I think we did this already, because I talked about, let's see, what was it? Catch and default. And while I talked about catch and default, of course, I talked also on case and something like that. Not catch, it was case and default. And then I talked about switch already. So this should be, let's make this one as well a little bit fast, because we already have talked so much about that. So for what we need a switch statement again? If we yes, let's write it short. If we want to choose from different options, something like that. Different options. And then we have this case, and then explain the examples on the page. And here we make it also a little bit fast, because we talked so much about this one, I think. Let's go and go to the switch. Where is my switch? Here is my switch. And let's see, here is it. Here is the switch statement. And here, yes, here important is again, yes, I hope you remember that where I talked 10 hours about this condition, why it looks a little bit strange here. And here important, this one here, it was not working on my machine because I have not this one. This one is for new compilers here, which support C++ 70. And if you don't have this one, it will not work like mice. So you have also check all time what you see here. And it looked, the next thing what was here strange is this init statements must be end with a semicolon, and here it is most time included here with this condition. And And then the next thing was here strange in this syntax, why it has here statement and no curly braces. Careful, we talked again much about this. The statement is only for one. If you have more statements, you should use curly braces here, something like that. And you can read here a little bit more in detail. And of course, we have here on top, this is just the start point here. We have here this 1 and this 2, and we learned you can use this one, but we know it can stay only here 2. But this one here, as a switch statement without case and case at least, is not this, let's say, the standard use, because normally if you have a switch statement, you want, of course, use cases, because you want, like I said here in my answer, we want choose from different options. That's why we want use a switch. You have here a condition, which is later integral, and depends on this condition you want choose, and then you will use cases. The default is only optional, but we should use that. And I talked about break. So I talked much about this already. That's why I hope you know what I'm talking right now, because yeah, we talk so much about this one. And I hope you know it better than me. If not, no worry, we are learning it. And let's go to the explanations, and we skip actually this explanation here on the bottom. Or is this right? Well, let's see. Let's see which we can make fast here. Let's see. Can you understand this one here very fast? I hope you can. So what we have here, if you see something like that, you can see instantly we have here an integral, a literal one, which means it will jump here, it will go here. And important, what happens here? What happens here in this example? What is the output? Just think about it. It says here 1. What do you think it's putting out here? If you say 1, it's right, but if you say 1, 2, it's even more right, because it will print out 1, 2. And why is that so? Because we have here no break, right? I said if we have no break and the case jumps in, and it will go till it finds a break, or here in this case till the end of the switch statement, which is also a more or less a break of this switch scope. But here in our case, it will go here, it will try to find a break. If there is no break, even it says here 1 is selected, it will jump to case 2 and it will print out this 1, 2. So it will print out here 1, 2. I hope you could see this. If not, no worry. That's why we repeat it. So here in this case, it's the same like before, but here we have a break. So what is the output here? Here it will only print out 1. You can see it. We have here a break. It will stop here. It will not go to this case here. Important is also we have here no default and something like that. Also, all right. Here we have even a new attribute here. And that's interesting mentioned, but we can see this one is the new version, which I said important. Watch this number here if your compiler is supporting that. My was not updated, so I used most time this online compiler to run this options. And this online compiler, what I use here is this compiler, and then you can click this copy inside and choose here. For example, I choose this, and then I could choose here the version. Here I have C++ 2070. Interesting is that they have not 23. Even this should be updated all the time. Or perhaps it's this one? I don't know. They have not 23. At least it's not really there. At least not as a number. So let's go on here with our switch statement. That was, let's see this here. Can you understand this one instantly and explain it? So it's again the same example actually from top, but we have here a little bit more things. We have here more statements, and interesting is this case has no curly braces, but of course you should make curly braces. Why we have here no curly braces? If you don't know and don't understand this kind of stuff, then what we have to do, so all time if you don't understand anything, just copy this code go into your IDE, jump into the and hope all is fine. Then you can paste it in. Let's see if I can paste it in. I don't know if I can paste it here, and I have to paste it here, I think. So here's my switch statement, and it's not going to work. Let's break it out and paste it here. And here I have to decomment this one. All time, if you don't understand anything, just copy and test all this test code here. Just test them and see what you expect. So it says it's initialized, it is printing out, it will stop, so it should be this one. And here it says default is used, and yes, this time we have a default, and you see they use default with break. You have not, but it's a good practice. We have talked about this break and default as well, why you should do this. In the reason for that is in future they can expand this one, and that's why they consider this one as a good practice, that you should make this. And compiler right here, it says would enter the scope of X without initializing it. And let's see what we have here. And it says here something where it what says why it's there on top. You know what, we are not needed this one actually. Let's make a comment, so start this one again. And I have still problems. And that means I hope this has nothing to do with my let's see if this has again to do something with my IDE. Go to the compiler. Like I said, all time when it's not working on my IDE, I go here to online compiler, I put in, and then I see what the real problem is. And in this case, it's not my IDE. Actually, it says here compilation failed. Let's see what the problem is. Excepted unqualified switch. What? Expected unqualified ID. Which? What switch? Okay, switch. All right. What is here the unqualified ID? Can you see the error here? As long as I make here something. Oh, yes, this was of course an error. I have to put it in main. Okay, let's put this one here. And let's delete the other things here. And now, oh no, I saved it. Now I go to the output, and it says here, jump to case label default here. Crosses initialization of int x. Int x is initialized. And what is this telling us now? It is telling us that I can't use it this way. And why? Do you see any problem here with this one? And default. All right. Let's see what we have here is this one here. Let's do this one also. Let's see what happens if I make a scope there. I should not make a scope there, but okay, I make a scope there. And now I have no problem. So what was the problem? You see that? What the problem was? And when I go here to copy insights, now I have no problem after I made a scope. And I think I talked about this one too. You should make a scope because then you are safe. And this case here, like you can see anyhow, it says compilation error, jump to default, would enter the scope of X without initializing it. Why? It's entering the scope of default without initializing it. That's really strange a little bit. The reason why this one is a little bit strange, because when I watch this one, normally what I expected is we go here to the switch, right? here's case 1, and then case 1 is here, and then yeah, okay, here, go here in, initialize X, stdc out, X out, and then break, and then it says here anything without scope. When I make it without scope, I would jump there. So, and yeah, and here, read this one. I don't know. Normally I would not expect this, but the reason why I not expect this is I use anyway all time a scope, so I'm sure that it is working. And if it's not working, then I have to watch why. Anyway, that was too long for this one. I was irritated, I admit it, but you see, make a scope here. All time use the, if you make here a case or whatever, just use this curly braces to be sure. If not, you have, like me, to check this, read and analyze, and let's say make more work than you have to if you use that. And let's go on. So what we have here, switch. In this case here is, we have here a switch, we have here a case, and here we have now the scope of X ends here. Yes, the same thing like before. Yes. The same thing like before with that what I made, which I would make all time. The declaring here, we start here, we end here, and here, no error. Yes, I saw this. I exactly made this. And yeah, read here the scope a little bit, and you see, exactly. That's why it was irritating. All right, let's go on. Read this one here. What I want to show you here, it's more important this one here. And try to understand, let's see, this one here. First, it's very easy actually, but important is here, again, when you go into this const int, like all time we declare a variable, it's a const. I will be put in, it will jump with 2, it will jump in this case here, but again, no break, which means it will here to write 2, it will go to 3, it finds here no break as well, it will jump to 5, and indeed it finds here 4, 5, so our output will be 2, 3, and 4, 5. But here, interesting, this one here, why is this interesting? Because we have a use case of this attribute. We have seen it, this all time, but in this case we see it, and it says here fall through. And this attribute, I think you can read and see what this means. And actually they describe it here, and it says here just silent the warnings of your compiler, so that the compiler is not complaining that here after the case 2 was found, that it jumping here and yeah, goes here. Read this a little bit, that's new, and a use case of this attributes, which here in this optional and in case places, which I said it's very rare to see. Most time we don't see it, in very rare cases, but when we see it, you have just to think about it. It starts with this double bracket, square brackets, and yeah, that's it. So don't be irritated by this, at least. There are other things which are more complicated than this, and then you should understand that. So let's go on. So let's try to understand this one here. What we have here, again, I is our const. It is not, this is a const, so we can't change it. It will be all time 2. It jumps here. 2 is not here at all, which means it will put out nothing because there is no cause. But that's not true. Careful. I is 2, I said here is nothing, but here is a default, which means even if I have not a case, this default will print out. So this 2 will indeed therefore default is executed. Yes, it says here it is executed. All right, 2 will be executed, D will print it out, which means in this case we print out D. All right, and here you can go on. I is again 2. In this case it prints out nothing. You can see we have no case, no break, no default, nothing. And Then here we talked also about this one again. This is just creating enumeration, and here I hope you know this one is the old enumeration declaration which we should avoid. I mean, we should now use enum class and enum struct instead of this enum. We talked also about this one. Why? Because the conversion behind the scene to intents or something like that, and if you use enum class, this one is a little bit more type safe and so on, which we have talked. And here in this case again, our switch, you can see normally you can't use words. That's very important to mention here. In this case, this words here are converted to numbers, right? You know this. We have talked about this. This enum starts here, for example, by default 0, 1, 2, and as an integral. So behind the scene, these numbers, these words can be converted to integrals. That's why it's allowed to put in here, because the switch says the condition must be a convertible integral, which means if you have a word and it can't be converted to an integral means something like a number, then it is not accepted. That's it. And yeah, that's this thing. Struct we can skip, and auto we have also not defined, we can skip. And switch 0, what happens here? Switch 0, and here we have just no, just again, no curly braces, but it's a statement. The statement doesn't have to be a compound statement, yes. This is also one of these rare cases. You can see we have here 0 input, but we have no case, we have no default, we have nothing. We have just a statement here, which is probably ignored in this case. And here in the last one, let's see here, this is also a little bit different. Here we have a declaration and an assignment. And then we have here, this one is more important. You can have a case which do nothing, has not any statement here. No break, and here no default, and yes. I think we talked about this, but I went again through, so I hope you was better than me, because yeah, if you read that and you see this the third, fourth time now, I think you get used to it, and that's the point here. That's why I repeat this. I could skip all this kind of stuff, but we repeated this during this exercise, and that is good. The reason for that is you get used to this documentation here a little bit, and you know it probably better than me soon. You can explain it soon to me how this works. And if this is the case, you learned it. You nailed it. And that's a good success if this is the case. And with that said, let's see, I talk so much. Can we do something more here? We can go to the questions, I think. I talk so much that I will skip the last one here. And the reason for that is this one needs, again, much explanation and examples. That's why I stop here, and like all time, if you have, again, any questions, any complaints, just write it in the comments. Don't worry to make mistakes. You see, I make many mistakes. Important is, and it will be, fix your mistakes. If you can fix your mistakes, you will be better soon. And this is one key feature of a programmer, to fix mistakes, especially if you want to get professional. This is, yes, I have never told this, right? A professional, if you want to go to a professional, one of your qualifications is you can find mistakes which other can't find. And that's why it's so important that you train to learn fixes which are simple, so that you get intermediate and professional to find things what, let's say, we starters, we random normals can't find. And that's why professionals get also paid very high, because if they make let's say, big projects, million, I don't know, a big project, game project, or a big other project where they spend millions in, and there occurs a mistake, right? And they want a programmer that they can find this kind of mistakes before they happen. I mean, what I mean before they happen is before, for example, the game is released, so that all the customers don't get, let's say, annoyed and really pissed that this kind of stuff happens after they paid it or something like that. And that's why, yes, learn to fix mistakes. Don't worry to make mistakes. That brings you only to more exercise. And like I said, if you want to get intermediate and professional, one qualification of a professional is he can find mistakes which are really difficult to find. And I talked also about this kind of mistakes. Don't forget, this kind of mistakes are the so-called critical mistakes, which is really danger, and you should avoid this one. So with that said, don't worry about mistakes, just fix them. It's just a part of a programmer. Make them, then you learn even more to fix mistakes like me, and you get better and better. That's the way to learn. Let's say that's one way to learn it. And with that said, if you have any questions like all time, any complaints like all time, write it in the comments, and bye, good luck, and don't give up.